Was in this video we'll be learning how to solve this question about plane triangles. Now when we talk about plane triangles are triangles that lie in what we call single plane, okay, meaning that all three vertices and sides of the triangle will be contained within a two-dimensional flat surface. Okay, so that's why when we draw a triangle, it looks like a what? This is like a flat surface. Okay, so it will be contained within a two-dimensional flat surface. Now, and when we talk about plane triangles, plane triangle is the foundation of basic geometry and trigonometry. When we talk about trigonometry, that's the word trigonometry is coined from two Greek words. The first one is trigono, okay, which means triangle. Okay, then the other word is metron, which means measurement. Okay, all right. So now when we talk about plane triangles, the triangles, the ones we know to be equilateral triangle, isosceles triangle, and what we call the scaling triangle. Okay, they are called the plane triangles. All right. So we have this question. The question reads: the sides of a triangle are 3, 7, and 8 units respectively. Prove that one of the angles is 60 degrees and calculate the other two angles to the nearest degree. Okay, that's question 1. Roman numeral 2, we want to solve this equation for 0 degrees less than theta less than what? 360 degrees. That means the value of theta will fall within 0 degrees and 360 degrees. Now, to be able to solve problems like this, we're going to employ the use of cosine rule, okay? Because when we have a triangle with 3 sides, we are giving the 3 side lengths without the angles. So it means we are going to apply one of the rule used in solving problems involving plane triangles, and that is the cosine rule. Cosine rule states that for any triangle ABC, okay, that's for any triangle with sides ABC, that is the lowercase letters of the alphabet will be used to represent the word. That's of the alphabet ABC will be used to represent the sides of the triangle, while the corresponding opposite angles or the corresponding angles opposite the sides, okay, will be labeled with higher case letters of the alphabet. All right, let's get into the video. So first, we need to analyze the problem. Okay, we need to analyze the problem. Okay, so to analyze the problem, let's first draw the triangle. Okay, the triangle will be scaling triangle, because in this case the side lengths are not equal. So okay, so we're going to let's put it this way. Let's consider a triangle ABC with sides 3 units, 7 units, and 8 units respectively below. Okay, so we have 3 units, 8 units. Let's say this is 3 units, and then this is 7 units. So this is 3 units. We have this to be 3 units. Okay, then we have this to be 7 units, and we have this side to be 8 units. Now the triangle is labeled with letter ABC, higher case letter ABC. So this will be A, okay, while this will be B, and this will be C. So which means the side opposite angle A, which will be represented with lowercase letter A, will be equals to 3 units, and that which is opposite angle B, okay, will be represented with lowercase letter B, and that will be equals to 7 units, and that which is opposite angle C will be represented with lowercase letter C, which is equals to 8 units. So like I said, by applying the cosine rule, okay, by applying the cosine rule. The cosine rule. Okay, the cosine rule. And I said the cosine rule states that for any triangle, okay, with sides A, B, C and and corresponding 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 angles A, B, and C respectively, okay, opposites with the sides. Okay, we have C square to be equals to A square, okay, plus B square minus 2AB cos capital letter what? C. So it states that for any triangle with sides A, B, C. Remember I said we always use the lowercase letters of the alphabet, to represent the side, opposites, the angles, okay, included in the what? In a triangle. And corresponding angles A, B, and C respectively, opposite with the sides, okay? So now, or opposite these sides. Okay, now we have C square equals to A square plus B square minus 2AB cos C. In this case, now remember we want to prove that one of the angles is 60 degrees and to also calculate the other two angles to the nearest degree. That's the first question. Now the second question is for us to solve the equation radical 3 cos theta minus sin theta equals to 1 for 0 degrees less than theta less than what? 360 degrees. Okay, so now in this case, we don't know which one of the angles will be exactly 60 degrees, but we can start from somewhere. Okay, we can start with angle A. All right, let's find out whether or not A will be, okay, the angular measure at A will be exactly 60 degrees. So to do that, like I said, we're going to apply the cosine rule. So now by using cosine rule, okay, we want to calculate now to calculate angle A. So we have cos A equals to, that will be equals to B square plus C square minus A square over what? 2BC. Now, based on the informations we have here, we know that A will be equals to 3 units, okay? B equals to what? B equals to 7 units, and C equals to 8 units. So A equals to, so in this case we have cos A equals to B, which is what? B is 7, and that will be 7 raised to the power of 2. Then C is what? 8. That will be 8 raised to the power of 2, while A is what? 3. And that will be 3 raised to the power of 2 over 2 times 7 times 8. So that cos A will be, this is 49 plus 64 minus 9. This will be 56. 56 times 2, that will be 112. Yeah. So that cos A will be 49 minus 9. That will be 40 plus 64 over what? 112. So that this will be cos A equals to 40 plus 64. That will be 104 divided by 112. Now let's divide this by 4. Dividing this by 4, this will be 26. Okay, let's also divide this by 4. Now dividing this by 4, this will be 28. Yeah, 28. Now let's divide this by 2. This will be 13, and this will be 14. So what we have now is cos A equals to 13 over 14. And we know from here that A will be equals to the inverse cos of 13 over what? 14. So what is 13 divided by 14? Yeah, so that'll be 0 point. So which means we're going to have angle A to be inverse cos of 0.925 0.9286. So we have the inverse cos of 0.9286. That will be equals to, so A will be equals to 21.8, and this is not equals to 60 degrees. So it means we have to proceed to the next one. But this will be approximately what? 22 degrees. So we have the value of angle A, that's angle at A, to be what? To be 22 degrees. Okay, so now let's calculate angle B. Calculate angle B, that's next. So in this case, we're going to have cos B to be equals to A squared plus C squared minus B squared over what? Over 2AC. Already we know that the value of A is 3, the value of B is 7, and that of C is what? 8. So this will be cos B equals to, now the value of A, that's 3. So we have 3 squared plus 8 squared minus 7 squared over 2 times 3 times 8. So that cos B will be equals to 9 plus 64 minus 49 over 6 times 8. That will be 48. Okay, that will be 48. So here we have 9 minus 49. That will be negative 40. Yeah, so that this will be cos B equals to 64 minus 40 all over 48. Then cos B will be equals to 24 out of what? 48. So that cos B will be equals to 1 over, this is 1 over 2. Yeah. 24 times 2 is 48. So the cos inverse of, that will be 60. Yeah. The cos inverse of 0.5, that will be 60. Okay, so this will be, angle B will be what? Cos inverse of 1/2. So that angle B will be what? 60 degrees. So this is the angle which is exactly what? 60 degrees. So angle at B is exactly equals to what? 60 degrees. So proven. Now remember that we also need to calculate the other two angles. So we calculated A. All right, so now we need to calculate C. So we're going to use one of the theorems of triangle. Okay, one of the theorems, that is the sum of angles in a triangle, okay, add up to 180 degrees. So that means we're going to use angle A plus angle B plus angle C equals to 180. Sum of angles in a what? Triangle is equals to 180. So angle A is approximately 22 degrees. Angle B is what? 60 degrees. Then angle C equals to 180. So we have C to be equals to 180 minus 82. So that this will be 180 minus 82. That will be 98. So we have angle A to be 22 degrees, angle B to be 60 degrees, and then angle C to be what? 98 degrees. And that's for question 1, Roman numeral 1. Okay, so Roman numeral 2. Solve the equation radical 3 cos theta minus sin theta equals to 1 for 0 degrees less than theta less than what? 360 degrees. So that means the value of theta will fall within 0 degrees and 360 degrees. So the first thing we need to do here is to what? Is to recall from one of the compound angle formula. You know, when we have, let's say we have, but in this case, this can be rewritten. Now we're giving the equation, let me put it this way. We're giving the equation radical 3 cos theta minus sin theta equals to 1. So because it is equals to 1, so we can rewrite the equation. Rewrite the equation as, this will be r sine, yeah, this will be sine, okay, yeah, r sine theta minus, let's say, alpha equals to 1. Yeah. And from here, we know that r will be equals to the square root of a squared plus b squared. That is the square root of the sum of the squares of a and b. So, and in this case, a will be radical 3, then b will be what? 1. B will be 1. So we're going to have our r to be equals to the square root of radical 3 square plus 1 square. Okay, it will be 1 from here. Or we can say, yeah, it will be 1. So in this case, so this will be r equals to 3 plus 1. So that r will be equals to radical 4. So that the square root of 4, that will be 2. So, so r equals to 2. Now let's get the value of alpha. Okay, so r equals to 2. Now let's calculate alpha. Now to calculate alpha, okay, to calculate alpha, now we're going to use alpha equals to the tan inverse of b over a. So we know that b is what? 1. So alpha equals to the tan inverse of 1 over root 3. Yeah, 1 over root 3. Now, tan of 60 degrees is radical 3, which is 1.732. Then tan of 30 degrees, that will be, yes, 1 over radical 3. So from what we call the similar triangle. So in this case, the inverse tan of 1 over radical 3 will be 60 degrees. Yes. So we're now going to what? We're going to plug in the values into this equation. So we have, you recall that we have r sine, okay, r sine theta minus alpha equals to 1. So now we know that r is what? The value of r is 2. This is it here. Okay, the value of alpha is 60. So 2, then theta minus what? 60 equals to 1. So when we divide both sides by 2 in this case, when we divide both sides by 2, so we're going to have sine theta minus 60 to be equals to 1/2. Okay, so that when we divide both sides by sine, so we're going to have, we'll take the inverse sine of this. So this will be theta minus 60 equals to the inverse sine of 1/2. Now the inverse sine of 1/2 is 30 degrees, because sine 30 degrees is what? Degrees, which is same thing as 1/2. So in this case, we have theta minus 60 equals to 30 degrees. So when this is moved to the other side, we have theta to be equals to 30 plus 60, and that will be 90 degrees. So we have 90 degrees. Okay, that is the value of x. If you represent this as x, will be either 30 degrees or 150 degrees. So which means when we say theta minus 60 equals to 30, and also theta minus 60 equals to 150 degrees. Yes, it's either it is 30 degrees or 150 degrees. And to get the value of theta from here, so we know that the first one will be 90 degrees, okay? Then the second value of theta will be 210 degrees, okay? So 90 and 210 degrees. So we have 90 and 210 degrees fall within 0 degrees and 360 degrees, meaning 0 degrees less than theta less than 360 degrees. And that is the solution to Roman numeral 2. The noblest pleasure is the joy of understanding. Bye-bye.